Section 7.8, models involving rational equations. So yes, models does mean word problems. We're going to start out by talking about ratio and proportion. A ratio is the quotient of two numbers or quantities, so a single fraction. A proportion is an equation of two ratios. So you would have something like this. And in this particular equation, we know that b and d cannot equal 0 because they're the denominators. A couple of terminology pieces. Means. In a proportion, the means are the b and the c in this equation. And the extremes are the a and the d. Because we have what's called the means extremes theorem. The means extremes theorem says if a over b equals c over d and b and d are not 0, then a times d equals b times c, or the product of the means equals the product of the extremes. We're going to use that, this is also called cross multiplying, to solve when we have a single fraction equal to a single fraction. So I'm going to take 64 times n minus 5 equaling to 8 times 56. Distribute. And then solve for n. So I'm going to add 320 and divide by 64 to get n equals 12. So working into our word problems, we need just a little example on setting up an expression. It says if Alice's age is represented by the letter A and Dan is twice Alice's age, write an expression for Dan's age. Well, it's twice Alice's age. Similar figures, we're looking at shapes like triangles. Similar figures have corresponding angles that are equal to each other and corresponding sides in the same ratio. If I have triangle ABC and triangle DEF, if triangle ABC is similar to triangle DEF, then the ratio of the corresponding sides is equal. So if I have side AC divided by side AB, then it's going to be the same as side DF divided by side DE. And that's just one of the pairs of sides. We also have this could also be written AC divided by DF, so we're jumping between the same side on two different triangles. Would be the same as AB over DE, so it's AB, DE. Or another example, I could have BC over AC. BC over AC would be the same as EF over DF. And there are other combinations you could make. These are just a few. What's important is that you pair up sides that are in the same relative location. So bottom with the bottom, the left with the left, the right with the right. So if we use similar figures to solve a problem, it says triangle ABC, I'm going to draw a picture, is similar to triangle DEF. Find the length of side DE given AB is 35, AC is 14, and DF is 10. So I can either stay within a triangle or I can jump between triangles. It doesn't matter which way you set it up. So if I go within my triangle, I have question mark over 10. So I went with left over bottom. So I need to make left over bottom. All right, I'm going to squeeze a variable in here. Let's make that x. Then cross multiply. 14x equals 35 times 10. 14x equals 350. Divide by 14, and we get 25. Is the length of DE. Another application of a proportion. A real estate agent knows that a 1,300 square foot house sells for this much. So how much would they expect a 1,700 square foot house in the same neighborhood to sell for? So if I have 1,300 square feet sold for $97,500, then a 1,700 square foot would sell for how much? So it's important that you line up the similar figures. 1,300 is square feet, 1,700 is square feet, so they're both numerators. So my costs are on the denominator. When I cross multiply, 1,300x equals, when I take 1,700 times 97,500, I would use a calculator. Actually, I don't even know what that answer is. Let's just write out 1,700 times 97,500. And then to solve, I would divide by 1,300. And then I would use a calculator, type all in at once, and get an answer of $127,500. So make sure your answer makes sense. It should be more because 1,700 is bigger than 1,300. So 127,500 is more than 97,500. Section 7.8 is a long section, so we're going to break it up. So this is the end of our first video for section 7.8.